kind of problem that's coming in this big test, right? Mathematics Olympiad. So we have problems about set, right? We have one problem here, one question here that we have to solve. That two different things we have to look, right? The problem is let A, look at this, be the set consisting of all sums of the squares of two integers. That is, look at this, A, this is the set, A equals x such x equals m squared plus n squared, where m and n belong to z, right? I mean the integer number. So okay, here C is the set of the integer numbers that's I told you. Okay, the first thing we have to show, look at this, we have to show that if s t belong to 8, then s times t belong to 8. All right. Number 2, show that if st, right, st belong to 8 with t different 0, then s over t equals p squared plus q squared, where p and q are rational numbers. All right. So let's go start then. So number one here. So let's see the process number 1 right here. Show that is s t belong to 8, then s times t belong to 8. We are going to prove that. Okay, first step, since s come t belong to 8, look, this is what it says. We are able to assume, all right, that, look at this, that s equals m2 over 1 plus n 1, right? And let's see, t, right here. Let me write different color here. T, right? It's going to be m 2, right, plus n 2, right? Where, okay, where m comma n comma m2 and n2, right, are integers. Right here. Okay, then hence now see the problem, right, the whole problem right now. So st we have to prove that right here. st equals, listen, look here, look careful, 2 to the second power 1, right, plus n to the second power 1, right, times m 2 plus n 2 to the second power 2, right here. See, do you see the problem right now? So simplify, factor, simplify, solve the problem, right? So we are going to have from this binomial, so we are going to have m21 times m22, right, plus n to 1 and n to 2, right? Plus, what else? M to 1, n to 2, right? Plus n to 1, m to 2. All right? Great. Then you have all development right here, ready. So now we are able to write look at, yeah, m1 times m2, right, plus n1 n2 to the second power, right? So now times, right, times m, right, 1 n2, right, n1 m2 to the second power, right? So we are proving this. We are in the first step, right? Which this, so which implies that all these ASC, right, ASC belong to A. Got it? So we have already the number 1. Okay, we proved the number 1. So now let's go and prove the number 2. Number 2, let's do number 2. Number 2. All right. Number 2, right here. Show that if ST belongs to A with T different 0, then S over T equals P squared plus Q squared, where P and Q are rational numbers. All right. So then here, since S, T belong to 8, right? By remember, by we prove actually number 1, the process of number 1 right here. We already proved. So right, this we're going to prove. We have ST belong to A, right? So we may look at this. We may, I am writing, we may assume, that, look at this, that ST equals m squared plus n squared, right? Where m and n, are integers. So are integers. For t different 0, then we are gonna explain all the information, all data. Look at this, step by step. Look at this formula. We have a development. So we are gonna have ST, right, equals ST right here. So ST to the second power, right? This is also equals m to the second power divided over t to the second power, right? Also, this equals n to the second power divided by t to the second power equals conclusion MT, the same thing to write it this way, right? Plus n t also to the second power, right? Where mt, let me write it, where mt, yes, and nt and n divided by t, are rational numbers. We are proving, okay, and the assertion follows. Okay? That's it. So this is the second proof, right? Show if the st belong to A with t different 0, then s divided by t equals p to the second power plus q to the second power, where p and q are rational numbers right here. See, right? S divided by t right here equals st divided by the second power, right? So equals the same thing to m to the second to divided by t to the second equals to n to the second power divided by t to the second power equals same thing m over t to the second power plus n over t to the second power. So where mt and nt, okay, are rational numbers. That is an assertion follow all information. So far that's the good answer for this problem with set. Okay, this problem coming from the Matemáticas Olympiad. So it's a big test, a big competition. So you guys, you wanna practice this kind of problem. This problem is ready for you guys. Study, take it. No, don't believe it to me. Just try to prove you guys by yourself. Prove all my information, and then